Alright, so to find the value of y, it follows that the same rule, we are using the same rule. Y is equal to 2x plus 1. So y is equal to 2x plus 1. To find y, let's substitute the value of x, okay, the corresponding value of the y in the domain into the rule, and then let's find the value of y. So when x is equal to -2, what will be the value of y? So then it follows that y will be equal to 2 multiplied by x. X is now -2 plus 1. And this gives us 2 multiplies -2. We have -4 plus 1. And this will give us -4 plus 1 will give us -3. Therefore, y is equal to 2x plus 1. So if when x is equal to -2, y will be equal to 2x. 2 multiplying x. X is -2 from here. So x is -2. 2 multiplies -2, then plus 1. That's what we have here. 2 multiplies -2, we have -4 plus 1. -4 plus 1 gives us -3. So the value of y using the rule gives us -3. Alright guys, so with question 22, this is what we have. In the diagram below, find the bearing of P from Q. The bearing of P from Q. The bearing of P. The bearing of P over here from Q. To find the bearing of P, that is the angle over here, from Q, this is what we do. Note that this is a right angle triangle. That is triangle QRP or PRQ. This is a right angle triangle because of this particular sign that we have over here. It makes it a right angled triangle. When this happens, take a look at QR, the length, and take a look at PR, the length. They are equal. So this particular length and this particular length are congruent. So it means if this length and this length over here, or this side and this side, are equal in length, it means that their base angles over here are also equal. And remember, this sign tells us that the angle over here measures 90 degrees. So how do we find the angle over here and angle over here? So there's an isosceles triangle. Two sides are equal. Those two sides that are equal leading to their base angles. Those base angles are also equal. But if the angle over here is A, the angle over here is also A. So if you add A to 90 degrees, it should be equal to 180 degrees. When you sum up the interior angles of a triangle, it gives you 180 degrees. So you add A over here to 90 degrees. And then you have it to be 180 degrees. When this happens, you add A to A, then you have 2A plus 90 degrees, which is equal to 180 degrees. Then you write 2A. This is 90. This is an angle. This is also an angle. It is positive over here. When it crosses the is equal to sign, it becomes negative. So you go and subtract it from 180. It is plus over here. So when it crosses the is equal to sign, it becomes minus 90. So bring the is equal to sign, right? 180 degrees. Then minus 90 degrees. 2A is equal to 180 minus 90 will give us 90 degrees. You can do that calculation. 180 minus 90. 0 minus 0 is 0. You can't subtract 9 from 8. So borrow 1 from here. 0 is left here. The 1 is 10. 10 plus 8 is 18. 18 minus 9 is 9. That gives us 90 degrees that we have over here. Repeat 2A is equal to 90 degrees over here. And then to find the value of A, we don't need the 2 over here. So divide here by the 2. Let the 2 go away. All right? Divide here by the 2. Let the 2 go away. So you divide the left-hand side by 2 and divide the right-hand side by 2. Always divide by the coefficient of the variable. So the variable is A and its coefficient is 2. So to find the value of A, to make A stand alone, you need to get rid of the 2. So we have to divide here by the 2 and go and divide here by the same 2. What you do at the left hand side, you do the same thing at the right hand side. That is what you have to note. So 2 divides 2, we have only a standing, and then 90 divided by 2 will give us 45 degrees. And because it is an angle, you write it as 045 degrees. Do we get it? It is an angle less than 100, so we write it as 045 degrees. So if A is 45 degrees, it means here is 045 degrees, here is 045 degrees, because they are all A. So the bearing of P from Q, the bearing over here, that is the angle of P from Q, will give us 045 degrees. And question 22 has been solved. Let's box on, take a look at question 23. All right, guys, so with question number 23, this is what we have. A polygon has 10 sides. Which of the following gives the sum of its interior angles? So if a polygon has 10 sides, what will be the sum of its interior angles? So this is how we go about it. We have a formula that we use to find the sum of interior angles of a polygon. And this is the formula. It is n minus 2 multiplied by 180 degrees. So n represents the number of sides of that particular polygon. So to find the sum of the interior angles of the polygon, the sum of interior angles of the polygon will be n minus 2. And n represents the number of sides. So n from the question is equal to 10. The polygon has 10 sides. We substitute the value of n, which is 10, into the formula that we have here. So n minus 2, so n is 10. So we have it to be 10 minus 2 multiplied by 180. And this follows that 10 minus 2 will give us 8 multiplied by 180. All right, so with the alternatives that are displayed over here, the options that are displayed over here, they didn't find the product of this. All we have over there is the number of sides multiplied by the angle 180. So with the possible answers that we have, the answer is 8 multiplied by 180. And we are done for question 23. So let's box on, take a look at question 24. And we are using the diagram to answer question 24 and 25. So I will display the diagram on the screen here, and then we take a look at how to find the answer to question 24 and 25. So from the question, the diagram shows the conversion graph for miles and kilometers. Use it to answer question 24 and 25. All right, so with this particular question, the x-axis we have distance in miles, the y-axis we have distance in kilometers. So 24 says find in kilometers the equivalent of 4 miles. We are finding in kilometers the equivalent of 4 miles. So let's see how best we can find the answer to this. To find the equivalent of miles in kilometers, search for 4 miles. Let's go to the miles column and then search for 4. This is where we have 4 in miles. And then trace it to meet this line over here. Do we get it? So let me use a ruler. This is where we have 4. There's the line that leads us to 4. So with 4 miles, move it up here. They intersect here. And then you trace it to the line that we have here. And then when you take each smaller box, it is 0.1. So this one will be 6.1, 6.2, 6.3, up to 6.9, then 7. Do we get it? So when you trace it up here, it meets the line, and there's the thick line that leads to 6. So when you count 1, 2, 3, it meets the 4th one. So it becomes 6.4, and that's what you trace here. 1, 2, 3, 4. That's what you trace it to. So it meets it 1, 2, 3, 4. That's the 4th one. So the answer to this will be 6.4. So 24. Find in kilometers the equivalent of 4 miles will be 6.4. Therefore, 4 miles over here will be equivalent to 1, 2, 3, 4 point, and that is 6.4. So we are done for question 24. Let's box on, take a look at question 25. Expressing 4 kilometers in miles, this is where we have 4 kilometers, all right? So if we trace it on the thick line to where it meets the drawn or plotted line over here, where it intersects, and we trace it down here. All right, so when we count from here, it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when you trace it up here, that is where 4 kilometers intersects. Do we get it? So it will be 2.12345. So expressing 4 kilometers in miles will be 2.5 miles. And we are done solving question 25. Let's box on, take a look at question 26. With question 26 and 27, we are using a diagram to solve the question. And the diagram will be drawn, and then we will use the diagram to solve the question. So this is the diagram that we have, and question 26 says we should find the length of xz. All right, so we have the length of yz, we have the length of xy, but we don't have the length of xz, which is the hypotenuse. So we are told to find the length of the hypotenuse. That's question 26. So we are finding the length of xz. That's what we are finding. So to find the length of xz, this is how we do it. You take the length of the hypotenuse. When you take the length of the hypotenuse and you square it, it should give you the length of xy squared plus the length of yz squared. Do we get it? So we are solving for the length of xz. So when you take the length of the hypotenuse, you square it, it will be equal to the length of xy squared plus the length of yz squared. So to find xz, we write this same thing again, and then substitute the values over here. So when we take the length of xy, it is 5 centimeters. So xy is 5 centimeters. So we take the 5, then we square it, plus yz squared. The length of yz is 12 centimeters. So we take 12, and then we square it. So the length of xz will be equal to 5 squared will give us 25. 12 squared will give us 144. So with the 144 that we have right now, let's find the sum of 25 and 144. So we have 144 plus 25. This gives us a sum of 9. This gives us a sum of 6. This is 1. So 169. So when you take sz squared, it is equal to 169 over here. To find xz, we have to express this in this form. Okay, so to find xz, to be equal to, now you see xz is squared, so what number multiplied by itself will give us 169? That is 13. 13 multiplies itself and you have 169. So it means that 169 will give us 13 squared. A number multiplied by itself will give us what? 169. That is 13 squared. Because over here, the powers over here are the same, it means the base over here are also what? The same. Therefore, the length of xz will give us 13 centimeters. And that is it. Or, better still, when we get here, we choose to find the square root of this and find the square root of that. And that gives you the answer 13. Either way, it works. So the answer to question 26 is 13. Let's box on, take a look at question 27. Question 27 says we should find tan yxz. So we are finding tan yxz. That's what we are finding. And yxz is the angle over here. Yxz is the angle over here, this angle. That's what we are calculating for. So tan yxz will give us tan of a particular angle is equal to the opposite of that angle over the adjacent of that angle. And when you take this particular angle, its opposite side is this length. Okay, the opposite side of this angle is this length, which is what? 12 centimeters. So 12 out of the adjacent side of this angle is the 5 centimeters. So that will be 5. Remember, this length is the hypotenuse, the longest side. With the options that we have 12 out of 5 in there. So the answer to tan YXZ is 12 out of 5. And we are done for question 27. Let's box on, take a look at question 28. Alright guys, so with question 28, this is what we have. The diagram shows 2 points P and Q in the number plane. Find the vector PQ. So we have the number plane and then we have these straight lines. The straight line has the points P and then Q. So the coordinates of P is what we have over here. Coordinates of P, -3 and then 2. And then the coordinates of Q are 3, -2. So to find the vector PQ, which is written as vector PQ, you subtract the coordinates of vector P from vector Q. So vector Q becomes OQ, then minus that of vector OP. This is the same as writing this as a small letter Q minus the P, that's the vector OP, becoming a small letter P. With the point Q, Q has the coordinate 3, -2, and then that is minus that of P. P has the coordinates -3 and then 2. So this is equal to 3 minus 3, which gives us 3 plus 3. So 3 minus gives us plus. So we have 3 plus 3. And then we have -2 minus 2. 3 plus 3 gives us 6. -2 minus 2 gives us -4. Therefore, the vector PQ is equal to 6, -4. And question 28 has been solved. Let's box on and take a look at question 29. With question 29, there's what we have. The question says we should find the length of the vector P, which is equal to -5 and 12. So we have the vector P, which is equal to -5, 12. So question 29 says we should find the length of this vector, which is P, equal to -5, 12. To find the length of a vector, we use a particular formula. X squared plus y squared. That is how you find the length of a vector. So to find the length of this vector, it is equal to x squared plus y squared. You take the x value, you square it, plus the y value squared. Then you find the square root of the final answer. So with this, the length of the vector P will give us the square root of x squared. X is also equal to, the value of x is -5. So we take -5, we square it, plus the y value is 12. So we take 12 and then we square it. So the length of the vector P will give us -5 squared will give us 25. It's -5 times -5, which is 25, positive 25. And then 12 squared will give us 144. That's what we have right now. So the length of the vector P will give us 25 plus 144. So let's find the sum here. Plus 25. 4 plus 5, 9. 4 plus 2, 6. And then we have 1. It is 169. So we have square root of 169 over here. Alright. So the length of the vector P will give us square root of 169 gives us 13. And that is the length. The length of the vector P. 13 units. So we are done solving question 29. Let's box on, take a look at question 30. With question 30, this is the question that we have. So the question says we should find the scale factor of the enlargement. So we have the area of the object, which is PQRS, and then the area of its image, which is P prime, Q prime, R prime, S prime. And we are told to find the scale factor. To find the scale factor, we use a formula, which is small k, which is equal to, over here we've been given the area of the We've been given the area of the object and then the area of the image. So we use the area that we've been given to find the scale factor. So this one becomes the area. To find the scale factor, it becomes the area of the image. The area of the image out of or over the area of the object. Do we get it? So over here we've been given the area in the question, the area of the object as well as the area of the image. So the image is the one with the primes. So the formula becomes area of the image all over area of the object. That's the formula that we use. So the area of the image itself, the image which is P prime, Q prime, R prime, S prime is equal to, the area is equal to 9 cm squared. And then the object which is PQRS has an area of 4 centimeters squared. So the scale factor now becomes area of the image, and the image is this, and its area is 9. Out of the object, area of the object, and the area of the object is 4 cm squared. So this gives us 9 out of 4. And the answer is not found there. So we have to change this to a mixed fraction form. So 4 will divide 9 2 whole times. There will be a remainder of 1 out of the denominator 4. So the final answer is 2 whole number 1 out of 4, and it is there. So the final answer to finding the scale factor of the enlargement gives us 2 whole number 1 out of 4. So we are done with question 30. Let's box on. Take a look at question 31. With question 31, we have a question on volume. So a volume of a cube is equal to 27 cm cubed. So the volume of the cube is equal to 27 cm cubed. And then the question continues to say find the area of one of its faces. So we are supposed to find the area of one of the faces of the cube. Good. For you to be able to find the area of one of the faces of the cube, there is the need for you to know the length of one of the faces of the cube before you'll be able to find its area. Do we get it? So to find the length of one of the sides of the cube, we need to find it by using the formula of volume of a cube. So the formula for finding the volume of a cube will give us of a cube is found by, because it is a cube, all the sides are equal. Do we get it? All the faces have the same shape. So all the faces are squares. We use the formula length multiplied by length multiplied by length. That will give us the volume of the cube. Do we get it? But we've already been given the volume, which is 27 cm cubed. So we are going to substitute this answer into where we have the volume of the cube, and then use the length of the sides in the formula to find the length of one side of the faces of the cube. So the volume of the cube is 27 cm cubed, 27 cm cubed, which is equal to L times L, which is equal to length times length times length. So 27 cm cubed will give us length cubed. Do we get it? Now, to find the answer to one of the lengths of the faces of the cube, L cubed means that L is multiplying itself 3 times. So 27 over here, to find the answer of one of the length of the sides of the cube, because the length over here is cubed, we need to search for a number that will multiply itself 3 times to give us 27. And that will give us the answer to the length of one of the sides of the cube. Do we get it? To find the length of one of the faces of the cube, we need to find a number that will multiply itself 3 times, because this means that L cubed means L times L times L. Do we get it? Good. So search for a number that will multiply itself 3 times to give you one of the length of one of the faces of the cube. So a number that will multiply itself 3 times to give us a product of 27 will be 3. 3 multiplies 3 Let me write it here. 3 times 3 times 3. So 3 times 3 gives us 9. 9 times 3 gives us 27. So 3 is 9. 9 3 is 27. So over here, the length of one of the faces of the cube will give us 3 centimeters. So it means that 3 times 3 times 3 will give us 27. Good. Now that we've been able to find the length of one of the sides of the cube, there is the need for us to find the length of one of the sides of the cube will give us 3 centimeters. When you get here, 27 cm cubed is equal to L cubed. L times L times L will give you L cubed. Do we get it? So L cubed means that search for a number that will multiply itself 3 times to give you 27. And that will be 3 times 3 times 3. That will give you 27. So the length of one of the sides of the cube will give us what? 3 centimeters. So now that we have the length of one of its sides, we can find the area of its faces. And the area of the face of the cube is a square. So it is the area of a square. Do we get it? So area of its faces is the area of a square, because the faces of a cube are all squares. Do we get it? And the area of a square gives us length times length. And over here we have the length to be 3 centimeters. So it is 3 centimeters multiplied by 3 centimeters. 3 multiplies 3, we have 9. And cm, we have 2 cm's multiplying. So cm squared. Because it is area, it is centimeter squared. If it is volume, it is centimeter cubed. Good. So the area of one of its faces, one of the cube's faces, is 9 centimeters squared. And that is it. We are done solving question 31. Let's box on. Take a look at question 32. Question 32 is a question on cylinder. So let's see how best we can solve it. The question reads: a cylinder is of height 3 centimeters and radius 2 centimeters. So the height of the cylinder, the height is equal to 3 centimeters, and then the radius is equal to 2 centimeters. The question says we should find its curved surface. The question I ask is, what's the formula for finding the curved surface of a cylinder? The formula for finding the curved surface of a cylinder is 2 pi RH. 2 is a constant here. Pi is 22 out of 7. It is constant. R is the radius. H is the height. But when you take a look at the possible answers that we have, they didn't solve the whole question because pi, the value of pi was not given. So the curved surface will be equal to 2 multiplying pi. Pi was not given, so just write pi over there. Multiply by the radius. The radius is 2 centimeters from the question. Multiply by the height. The height is 3 centimeters from the question. So let's multiply everything. 2 multiplies 2 is 4. 4 multiplies 3, we have 12. So we have 12 times pi. So 12 pi. Do we get it? And because it is curved surface area, because it is area, we have to bring the unit cm squared to make it correct. The unit for area will be meter squared, centimeter squared, millimeter squared, kilometer squared, whatsoever. But it's supposed to be squared. The unit is supposed to be squared. That will give you the area. So the surface area of the cylinder gives us 12 pi cm squared. And question 32 has been solved. Let's box on. Take a look at question 33. So we have a question on parallelogram. The question says, find the area of the parallelogram PQRS. So the diagram is displayed on the screen. And let's look at how to find the area of this parallelogram. The formula that we use to find the area of a parallelogram is length of the base multiplied by the perpendicular height of the parallelogram. So from the diagram, the length of the base of the parallelogram is PQ. All right, the length of the parallelogram, the base. So to find the area of a parallelogram, area of a parallelogram, it will give you a formula: length of the base multiplied by length of the perpendicular height. So length of the base multiplied by length of the perpendicular height. That's the formula we use to find the area of a parallelogram. And from the diagram, when you take a look at SR, the length of SR gives you 12 centimeters. It is in the diagram. XR measures 12 centimeters. And you know SR and then PQ are parallel lines. Therefore, if SR is equal to 12 centimeters, it means that, therefore, if SR, the length of SR is 12 centimeters, it means that the length of PQ is also 12 centimeters. So SR is also equal to 12 centimeters, and that is also equal to the length of PQ. So SR is equal to PQ, and they all have this same 12 centimeter measurement of their lengths. Their lengths are the same and they are parallel, so their measure is 12 centimeters, and the length of the perpendicular height is 4 centimeters. So the height is 4 centimeters. So substituting everything into the formula, the area of the parallelogram will be equal to length of the base, and the length of the base is 12 centimeters. Because SR is also equal to PQ, they are parallel lines, so the measurement of their lengths will be the same. So the length of the base is 12 centimeters multiplied by the perpendicular height, the length of the perpendicular height, and the height is the one with the short dashes, which is 4 centimeters. So 12 multiplies 4, and then we have 48. 4, 2, we have 8. 4, 1, we have 4. Because it is area, it is centimeter squared. So we are done solving question 33. Let's box on, take a look at question 34. With question 34, this is what we have. If 1/3 of a number is added to 1/5 of the same number, the result is 8. Find the number. So there's a word problem. So let's try and get it solved. 1/3 of a number. If 1/3 of a number is added to 1/5, so the number that we are finding 1/3 and 1/5 of, we don't know that particular number. So let's use a particular variable to represent this number. So let B represent the number. So if B is representing this number, then the question says if 1/3 of the number, so you find 1/3 of means multiplied by the number, and the number is B, so 1/3 of the number, and then if 1/3 of the number is added to 1/5 of the same number is the B, so you find 1/5 of the same number, of means multiplication, and the number is B. All right, so if 1/3 of a number, and then the second sentence says 1/5 of the same number, so this is 1/5 of the same number. But from the beginning, the question says that if 1/3 of the number is added to, so you add 1/3 of the number to 1/5 of the number, and the result or the answer will give you 8. Do you get it? So let's add 1/3 of B to 1/5 of B. So we have 1/5 multiplied by B plus 1/3 multiplied by B, and the answer or the result will give us 8. That is the expression we get out of the word problem. And if we have this, we need to solve the ones here in the bracket first. We need to multiply this one, and then add. So you find 1/5 of B, and then you have multiplying B will give us 1 out of 5 B plus 1 out of 3 multiplying B will give us 1 out of 3 B, which is equal to 8. So from here, let's find the LCM of 5 and 3. In other words, if over here, if you are multiplying, you could write it as 1 multiplies B, you have B. So it could be B out of 5. And then over here, when 1 multiplies B, you still have B, which is B out of what? 3. the same thing. If you write it this form too, it's not wrong. And if you write it the other way around, it's not wrong. The LCM of 5 and 3 will give us 15. So you multiply this by 15, multiply this by 15, and multiply here by 15. So 15 multiplied by 1 out of 5, B, plus 15 multiplied by 1 out of 3, B, which is equal to 8 multiplied by 15. And over here, 5 divides itself a single time, divides 15, and we have 3 times. Over here, 3 divides itself a single time, divides 15, then we have 5 times. So 3 multiplies 1 out of 1 is 1. 3 multiplies 1, you have 3. So you have 3b over here. Plus, over here, 1 out of 1 is what we have here. That is 1b, which is b. 5 multiplies b, we have 5b, which is equal to 18 multiplies 15. Let's find the product here. 8, 5, 40. We write 0, remainder 4. 8, 1, 8 plus 4 is 12. 120. So 3b plus 5b will give us 8b, which is equal to 120. Let's rewrite this same thing over here. 8b is equal to 120. To find the value of b over here, we need to divide this expression by the coefficient of b, which is 8. Go and divide here by the same 8. 8 and 8 will be gone. We only have b left. All right. So what number can divide both 8 and 120? 8 can do that. 8 divides itself a single time. 8 divides 12. Then you have a single time. There will be a remainder of 4. Bring the 4 in front of this 0. You have it to be 40. 4 and then 0 together will give you, not summing them together, but just bring the 4 in front of the 0. Then you have 4 and 0, which is 40. So 8 will divide 40. Then you have 5 times. So b will be equal to 15 out of 1, which will give you 15. All right. So the final answer that we have for this is 15. Take a look at this. When you find 1/5 of b, now b is 15. So 1/5 of b, which is 15, 1 out of 5 of 15 will give you 3. The whole 1 out of 5 multiplying 15 will give you 3. And then 1 out of 3 multiplying 15, which is the b, will also give you 5. And then 3 plus 5 over here will give you 8. So we are done solving this. So we are done solving question 34. Let's box on, take a look at question 35. All right, so with question 35, this is the question that we have. If 1 to x is equivalent to 6 whole number 1 out of 4 to 25, find x. So let's write the question down. So this is what we do. Express this as an improper fraction, and then we write the whole mathematical sentence as a fraction or as a common fraction. Equate them. Equate the common fractions. So 1 to x will be equal to, changing 6 whole number 1 out of 4 to improper fraction, we have 6 multiplies 4, we have 24, plus 1, we have 25 out of 4 to 25. Now let's express this whole thing, this one as a common fraction. So we have 1 out of x. Then express this as a common fraction, we have 25. This is 25 out of 4 over 25. So with what we have, we cross multiply. 1 multiplies 25, x multiplies 25 out of 4. So 1 multiplies 25, or x multiplies 25 out of 4 first. So x multiplies 25 out of 4, which is equal to 1 multiplying 25. So this is what we have now. X multiplies 25 out of 4. We have 25 out of 4x, which is equal to 1 multiplies 25. We have 25. All right. That is what we have. So to find the value of x over here, you can choose to divide this whole expression by 25 out of 4 and go and divide here to by 25 out of 4. So I'm going to rewrite this same thing. And then 25. I'm going to divide this whole expression by 25 out of 4 and divide this whole expression by 25 out of 4. So 25 out of 4 and 25 out of 4 will be gone. Let's come up here. We will be left with only x over here, which is equal to, this is 25 out of 25 out of 4. So it is 25 divided by 25 out of 4. So it is 25 divided by 25 out of 4. X will be equal to 25. Division sign changes to multiplication. 4 goes up, 25 comes down. Reciprocal. Then X will be equal to, we can write this 25 as over 1. So 25 over 1 multiplied by 4 out of 25. There are some common factors here that can divide. 25 can divide itself a single time and divide this 25 a single time. All right. So we have 1 multiplying 4. Then we have it to be 4. When 1 multiplies 4, it is 4. When 1 multiplies 1, we have 1. And this will give us 4. 4 out of 1 is 4. All right. And that is it. The answer to question 35 is 4. All right. So with question 36, this is what we have. We are expressing 3 out of 8 as a percentage. 3 out of 8 as a percentage. So to express a number as a percentage, multiply the number by 100. So we have a fraction, a common fraction, 3 out of 8. And we are expressing this as a percentage. So to express 3 out of 8 as a percentage, multiply it by 100%. And then moving forward, there are some common factors that can divide this and that. So 4 divides this 2 times, and then 4 divides this 25 times, because 4 will divide 10 2 times. There will be a remainder of 2. Bring the 2 in front of the 0. You have 20, and the 4 will divide it 25 times. So now you have 3 out of 2 multiplying 25%. There are no common factors that can divide, so let's multiply 3 by 25. Okay, so 25 times 3. 3 5 15, remainder 1. 3 2 is 6. 6 plus 1 is 7. So 3 multiplies 25. We have 75 all over 2%. To make it clear enough, you can write this as over 1. Before you multiply this by this and this by that. You multiply this by this, you have 75. This by that, you have 2. 2, 1 is 2. That's why we have 2 here. Let's box on. So with this, we've got to divide. When you look at the possible answers that we have, the appropriate answer is not there. So the correct answer is not there. So let's divide and then find the answer to this. 2 divides 7. Let me rewrite the same thing here. 75 out of 2%. 2 divides 7 3 times. 2 divides 7 3 times. 2 3 will give you 6. There will be a remainder of 1 here. Bring the 1 in front of the 5. Then you have it to be 15. 2 divides the 15 7 times. 2 7 is 14. There is a remainder of 1 here. So you write the remainder 1 as a numerator over the denominator 2. So the final answer that we get from this is 37 whole number, 1 out of 2%. And the answer is there. So we are done solving question 36. Let's box on. Take a look at question 37. There's what we have for question 37. Akosua buys 480 pineapples for 24,000 cedis. She sells all the pineapples for 28,000 cedis. Find her profit percent. And it's quite clear, before you'll be able to find profit percent, there is the need for you to find the profit first before you calculate for the profit percent. So from the question, what is the cost price? The price at which Akosua bought the 480 pineapples. He bought them at 24,000 cedis. That's the cost price. So I will use CP for cost price, which is 24,000 cedis. This is the pesos unit. And then she sells all the pineapples for 28,000 cedis. So the selling price, the price at which she sold all the pineapples, is 28,000 cedis. As I said earlier, we need to find the profit first before we calculate for the profit percent. And the formula we use for calculating profit is the selling price minus the cost price. All right? And the selling price is 28,000 minus the cost price. The cost price is 24,000. And this is cedis. So 28,000 minus 24,000. 0, 0, 0. We are subtracting. 8 minus 4 gives us 4. 2 minus 2 gives us 0. Not needed. That's the last subtraction. So it is 4,000 cedis. So the profit gives us 4,000 cedis. That's the profit. To calculate for profit percent, we use a formula, and the formula is profit over the cost price times 100%. That's the formula we use to solve profit percent. So from the question, what is the profit? The profit is 4,000 out of the cost price. The cost price is 24,000 multiplied by 100%. So we've got to divide, okay? Divide here by 10, divide here by 10. This 0 and this 0 will be gone. Divide by 10 again. Divide here by 10 and divide here by 10 again. This 0 and this 0 will be gone. Divide here by 10 and divide here by 10 again. This 0 and this 0 will be gone. So it means we have divided here by 1,000 and divided here by 1,000. So all the 3 zeros are gone. 1,000 has 3 zeros. So all these 3 zeros are gone. And then the final thing we have over here is 4 out of 24 times 100. And let's continue dividing. 4 will divide itself over here a single time and divide 24 6 times. 4 will divide 24 6 times. So we have 1 out of 6 times 100. That's what we have right now. So we have 1 out of 6 multiplied by 100%. That's what we have right now. And moving forward, when 1 multiplies 100, we have 100 out of the 6%. So we have 100 out of 6%. So let's divide 106 and see the quotient that we are going to obtain from this. All right. So let's divide over here. Let's use the long division method and divide over here. So 100 in here, 6 out. How many times can 6 divide 10? 6 divides 10 a single time. 1 multiplies 6, we have 6. Let's find the difference. We can't subtract 6 from 0. We borrow 1 from it, then we have 10. So 10 minus 6 gives us 4. So 10 minus 6 is 4. Then 6 can't divide 4 over here. For that reason, bring this 0 down. You have 40. 6 divides 40 6 times. Because 6 times 6 gives us 36. All right. You find the difference over here. 0 minus 6 is not possible. Borrow 1, you have 10. 10 minus 6 gives us 4. Over here, 3 is left here. We have a remainder 3 here. So 3 minus 3 gives us 0. So we have only 4 left here. All right. 6 cannot divide 4. And there is no number to bring down again. Because of that, bring a decimal point and then add 0 to this. We are entering into the decimal value. All right. 6 divides 40 and it is 6 times again. Over here, 6 divided 40, we have 6. 6 is dividing 40, we have 6 again. 6 will give us 36. You find the difference, it will still give you 4 again. The difference will give you 4 again. So when you continue, you will still have 40. And then the 40 will continue to be recurring. It will continue like that. And then you'll be dividing and you'll be having 6, 6, 6 like that. So for this reason, all the answers over here have been left to 1 decimal place. Do we get it? So let's express this in 1 decimal place. You only have to add 1 to this 6. After the decimal point, we have only 1 digit here. That's the digit in the first decimal place. The first decimal value is 6. So check the other number. If it is more than 4, you can add 1 to this to convert it to 1 decimal place. So you add 1 over here to this, then you have 7. So it gives you 16.7 and this percent. And this is the answer to the question. So it is 16.7%. And we are done solving question 36. Let's box on. Take a look at question 38. And with question 38, it's just a simple question. How many edges has a cuboid? Let me get a cuboid and then explain it to you. So this is an example of a cuboid. So these are the edges of the cuboid. These are the edges of the cuboid. So to find the number of edges that the cuboid has, count the number of edges. So we have 1 here, 2 here, 3 here, 4 here. All right, and then we have 5 here, we have 6 here, and then we have 7 here, we have 8 over here, and then when we turn it upside down, we have 9 here, 10 here, 11 here, 12 here. So when you count all the edges around the cuboid, you have it to be 12, and this gives us the edges of a cuboid, and it is 12. So question 38 has been solved. Let's box on, take a look at question 39. With question 39, we are using a pie chart to solve the questions 39 and then 40. So let's get the pie chart drawn. So this is what we have for the pie chart, and the question says the pie chart shows the distribution of crops on a farm of area 250 hectares. Use it to answer questions 39 and 40. So we have the crops on the farm, and we have okra, corn, cassava, pepper. And with okra, its angle is 80% corn. When we take a look at the shape, this looks like this is the 90 degrees angle. So if they don't write anything over here and they use this particular sign, it means this angle over here is a right angle. So that measures 90 degrees. So over here measures 90 degrees, though it was not written in the question, but because of this sign that we have here, it means it's a right angle and it measures 90 degrees. Cassava is 70 degrees. Pepper, the angle for pepper is not given. So let's look at question 39, what it demands that we solve for. It says find the area of the plot with corn. The area of the plot with corn. So to find the area of the plot with corn, this is how we go about it. It will be the angle for corn out of the total angle multiplied by the hectares of farm that we have. So let's write down the hectares of farm that we have. All right. So the area of farm is equal to 250 hectares. The total angle, total sectorial angle. The total sectorial angle is always equal to 360 degrees. The circle all around has an angle of 360 degrees. So that's the total sectorial angle. So to find the area of plot with corn, area will be equal to the angle for corn, which is 90 degrees, out of the total sectorial angle, 360 degrees, multiplied by the total hectares of farm that we have, 250. So we divide here by 10, here and here by 10. This 0 will be gone, this 0 will be gone. Then we have 9 out of 36. 9 is a factor that can divide 9 and 36. 9 divides itself a single time. 9 divides 36, and then we have 4. So we have 1 out of 4 multiplying 250. So 1 out of 4 multiplied by 250 hectares of farm. Let's see the value that we'll get for this. 1 multiplies 250, we have 250 out of 4. Let's see what we are going to get out of this. Let's bring it down here. 4 divides 25, 6. We have 6. And there will be a remainder of 1 because 6, 4 is 24. So bring that remainder 1 in front of this 0, and then you have 10. 4 divides the 10 2 times, and there will be a remainder of 2. 4 cannot divide the 2. So bring the decimal point, add 0 to the 2 that is left, so that you have 20. All right. Then 4 will divide the 25 times, and then you have 62.5 hectares of farm used for the cultivation of corn. All right. Or if this division is difficult for you, you can use the long division. All right. 4 divides 25, you have 6. 6, 4, 24. Find the difference between 25 and 24. It is 1. 5 minus 4 is 1. 2 minus 2 is 0. But we can't write a 0 here. We only leave the 1 here. Then bring the remainder of this 0 down here. Then 4 divides 10, you have 2. 2, 4, you have 8. Find the difference. 10 minus 8 gives us 2. You can't subtract 8 from 0, so you borrow 1 from here, then you have 10. Then 0 is left here. 10 minus 8 gives us 2. So with the remainder 2, 4 can't divide the 2, so bring a decimal point here. Add 0 to the 2. Then 4 divides 20, you have 5 over here. So it is 62.5 hectares. That's what we have over here. I believe it has gone down well with us. So let's move from question 39 as it has been solved. The final answer is 62.5. Let's box on and take a look at question 40. What fraction of the farm is planted with pepper? So it says what fraction of the farm? It says what fraction of the farm is planted with pepper? We need to calculate for the angle that is representing pepper. Alright, calculate for the angle that is representing pepper, and then express the angle for pepper and the total sectorial angle in a common fraction form, and that will give you the answer to question 40. So let's find the angle for pepper. To find the angle for pepper, sum up all these three angles, 1, 2, 3, and subtract it from the total sectorial angle, which is 360. So the angle for pepper. So the angle of pepper will be equal to 360 degrees minus 80 plus 90 plus 70. So 80 plus 90 plus 70 degrees. So add 80 to 90 to 70. 80, 90, 70. Let's add. All of these will give us zeros. 8 plus 9 will give us 17. 17 plus 7 gives us 24. So we have 240. This gives us 360 degrees minus 240 degrees. Let's find the difference of 360 and 240. 360 minus 240. 0 minus 0, 0. 6 minus 4, 2. 3 minus 2, 1. So we have it to be 120 degrees. We have it to be 120 degrees. 120 degrees. This is the angle that is representing pepper over here. That is 120 degrees. So the final question says, what fraction of the farm is planted with pepper? Fraction of the farm planted with pepper. And that will give us the angle for pepper, which is 120 degrees, out of the total sectorial angle, which is what? 360 degrees. Leave this in the simplest form. Divide here by 10, this 0 will be gone. Divide here by 10, this 0 will be gone. So we have 12 out of 36. 12 can divide itself a single time and divide 36 3 times. So we have it to be 1 out of 3. Therefore, the fraction of the farm planted with pepper gives us 1 out of 3. And this brings us to the end of the 1992 objective test here. I'll urge you to follow the solving of the past questions on this channel, and please do well to subscribe to my channel to keep the channel growing and growing and growing. Watch out for more lessons on specific topics related to maths, as well as we solve the past questions. So solving the past questions will be treating certain topics in mathematics alongside the solving of the past questions. So right now, I'll bid you farewell and I'm out of here. Meet you on the next episode. Bye bye.